Hello students. So far we have learned the elimination method of solving linear equations in two variables. That is elimination by equating the coefficients and elimination by substitution. Also we have learned the ASA method, which is the add subtract add method. Now it's time for us to start with the next method of solving linear equations in two variables, and that is the graphical method. Now I'm sure you all must be wondering how exactly we can solve a linear equation using a graph. I mean, what exactly is the concept? See, the concept is linear equation in two variables basically represents a straight line on the graph paper. Now I'm sure you must be wondering what exactly does this mean? I mean, what do we mean by a linear equation representing a straight line on the graph paper? Now see, say for example, there is a linear equation x plus y is equal to 5, right? Now there are different solutions possible, like 2 plus 3 is equal to 5. So 2 comma 3 is a solution. Then 3 comma 2 can be a solution, 4 comma 1 can be a solution, 0 comma 5 can be a solution, right, of the equation x plus y is equal to 5. Now the solutions that I mentioned, when you plot these points on a graph paper, you will always get a straight line, and this happens only in linear equations. That's why we say a linear equation in two variables always represents a straight line. That's why the name linear line. That's why it is called as the linear equation in two variables. So always remember this, whatever solutions or whatever values of x and y that satisfies a given linear equation in two variables, when you plot them on a graph paper, those points will always be collinear and you are bound to get a straight line, right? So basically in graphical method, what happens, we need to plot points, we need to join them, we will get two straight lines. The two lines will be intersecting at a point, and that will be the solution. That is what the concept is. But before we start plotting the points, you should always keep your graph paper ready like this. In the sense, both the lines should be at the center of the graph paper, right? You should mark the axis properly, like x, x dash, y dash, where x represents the positive side, x dash the negative values, y positive, y dash negative, right? Don't forget to mark the origin. And don't forget to write the scale, and scale will always be 1 centimeter is equal to 1 unit on both the axes. So either you can write on x axis 1 centimeter is equal to 1 unit, on y axis 1 centimeter is equal to 1 unit, or you can directly write 1 centimeter is equal to 1 unit on both the axes, right? So proper lines at the center, axis x, x dash, y dash, origin, scale. And the numbers that you write, the coordinates that you write, the x coordinate should be written below as shown here, and y coordinate should be written to the left of it. Always remember this, right? And after doing all this, don't forget to write the question number on the top, right? The question number should be written with a pen, but rest all should be done with a pencil. Remember this, okay? So after the graph paper is ready, you are given two linear equations in every sum. So you will get two lines, each line representing a linear equation. So we need to find the values of x and y that satisfy that linear equation. We will teach you how to do it, right? Ultimately, you will get two lines like this. After you get these two lines, just check the point of intersection. Like here, the point of intersection is minus 3 comma 4. Now, because the point of intersection is minus 3 comma 4, we come to a conclusion that x is equal to minus 3 and y is equal to 4 is the solution of the given linear equation. As simple as that, right? So always remember this. What is the concept of a graphical method? A linear equation represents a straight line. Okay, how do you get this straight line? All that we will teach you, don't worry at all, right? So two linear equations represent two straight lines. Both the lines intersect at a point. The point of intersection is nothing but the solution, right? One more important thing. Now say if there was only one equation, we would have got just one line. A line is made of infinite number of points, right? That's why we say a linear equation in two variables has got infinitely many solutions. That's why in every sum, we are given two linear equations in two variables so that we solve them simultaneously. We get their point of intersection, which is the answer. So this answer satisfies both the equation. That's why it is the point of intersection, right? That's why they are also known as simultaneous equations, because we are solving two equations simultaneously. So I'm sure with this, lots of your concepts with regards to linear equations must have got clear. One, a linear equation represents a straight line. That's why linear. Two, why we are given two linear equations in two variables, so that we get one unique solution when we solve them simultaneously. If only one linear equation is given, it will have infinitely many solutions, right? And the solution of a linear equation in two variables is nothing but the point of intersection of two lines, right? Now the question is, what are the rules to find those points? How do we approach a sum based on graph? Now see, you will be given a linear equation like, for example, 3x plus 2y is equal to 6. So the first thing is we need to find the values of x and y which satisfies the given equation. So to do that, the first thing what we advise to do is write the equation in the form of either x is equal to something or y is equal to something. That is, you need to shift one of the two variables to the other side along with the constant. It is always preferable to shift the variable with the bigger coefficient to the other side. That's why it is written, it is preferable to keep the variable with the bigger coefficient and the constant term, 6 in this case, together. Right? So here what we will do is, we will shift the variable with the bigger coefficient. Now what is the bigger coefficient here? 3x. Let us shift 3x to the other side and you get 2y is equal to 6 minus 3x. Right? After that, what I said, we need it in the form of either x is equal to something or y is equal to something. What we have right now is 2y. So we need to take this 2 to the other side. So we get y is equal to 6 minus 3x upon 2 and we get the equation in the form of y is equal to something. So that's the first thing that you all need to do. Write the equation, the given equation in the form of either x is equal to something or y is equal to something. Right? Now here just an error which normally students do, they see 6, they see 2, they get excited and they cancel 2 3s are 6. Never do that because there is a minus sign here, so that is not allowed, right? Now once you do that, you need to draw a table which will have x values, y values and x comma y, that is the coordinates which we will be plotting on the graph paper, right? So how do we get this? Whichever variable is there in the right hand side, here which variable is in the right hand side? X. So whichever variable is there in the right hand side, assume any 4 values of that variable, any 4 values of your choice. But those values should be plottable on the graph paper. So we generally in most of the sums advise to take the value of the variable as 0, 1, 2 and 3. Okay. So here in this, if this is a sum, the right hand side variable is x. So we will assume 4 values of x, that is 0, 1, 2 and 3. Once we assume the 4 values of x, then keep on substituting those values of x in this equation and you keep getting the corresponding values of y. So you get 4 values of x, substitute in the equation, you get 4 values of y. So you get 4 set of points, you get 4 set of coordinates, which when you plot on the graph paper, all the 4 points would be collinear, join them, you get a straight line. Repeat the same for the second equation which will be given. Again, plot it on the graph paper, you will get one more straight line. Both the lines would be intersecting at a point and the point of intersection will be nothing but the solution. As simple as that.